go from a graph and completely write a function, a possible function. This is a rational graph because what you have here are vertical asymptotes going on all over the place, okay? So remember, a polynomial graph you would recognize because it would be smooth and continuous. There would be no breaks in it, no verticals at all. Okay, so what we need to know from a graph to a function is that you've got the zeros, which create the numerator linear factors, and you've got the verticals, which create the denominator linear factors. And the horizontal would tell you something about the coefficient. All right, so let's write a name for this function. Let's just call it, I don't know what, h of x. H of x. I'm going to zoom out here a bit so you can see it better. H of x. So we're going to look at these zeros here. So I'm going to create a linear factor for this. It's passing through. So it's got to have odd multiplicity. So I'm going to call that x plus 4 with a 1 power on it because it's odd. Here is another one at 0. So that's x minus 0 or just x. Okay, but this one is bouncing. So I got to give that some kind of even multiplicity. So I'm going to say 2 on that one. Okay, we're just kind of going for it right now. All right, pass, a bounce. So odd multiplicity, even multiplicity. And look at this graph here. Look what's happening to this part of the function. It is crossing through the horizontal asymptote. Is that allowed in the middle? Yes, it is allowed in the middle. Horizontals are about end behavior. Far right, far left. We don't care if the function crosses over at 100,000 times in the middle, as long as at the very ends it's following the horizontal asymptote. So that is allowed, yes. Okay, so we just did the numerator, pass, bounce. Here it is. All right, let's do now the denominator. So I want to get some paper here so I can show you. The denominator is all about the vertical asymptotes, which is the forbidden zone. There, your function can never cross. Never, ever, ever. I don't want to see that on anyone's test. Okay, so here we go. Look at what's going on around here. This is the vertical asymptote, x equals -2. Look at what the function's doing on either side. One end up, one end down. If they are pointing in opposite directions, your function, around the vertical asymptote, then you have odd multiplicity. So let's create a linear factor for that. I'm going to call it x plus 2. Okay, just like you do with these. Okay. Okay, so this is x plus 2 with odd multiplicity because your function's going in opposite directions around it. So I'll just leave it as 1. And then look at this one over here. Functions both going in the same direction. Both ends are pointing up around this vertical asymptote. So I'm going to write the linear factor for that one, x minus 2. And then it's going to be what you call the even multiplicity, or the vertical bounce, which sounds kind of silly right there. Okay. Now you've got one thing left, which is your horizontal asymptote, and it is 3. So that's going to become the coefficient of your rational function. So let's just look at the overall multiplicity here, the overall degree rather. 1, 2, 3, and 1, 2, 3. So yes, numerator and denominator both have the same degree. So that's why we can put that coefficient out there in the front. We have to check that. Okay, let's do another problem. Now this is going to be more complicated a bit. We are going to go from a function and we're going to have to graph it. Okay, so I'm going to write the graph down as we go along here. So the first thing that you want to do is plot the x-intercepts from these linear factors. So I'm going to write that down here. I'm going to make a graph. Okay, there's your x and your y. axes. So we have right here and right here. So at x equals -3, we have an x-intercept, and at x equals +2, we have an x-intercept, okay? The next thing we'll do, so that's part one, the zeros, okay? Part two, we're gonna do the vertical asymptotes. What can x never equal? X can never equal -1, so I'm just gonna make a vertical asymptote right there at x equals -1. And then another vertical at x can never equal 4. So I'm going to draw another one right there. X equals 4. Not allowed. Not allowed to have x equals 4, otherwise that whole thing equals 0. You can never have 0 in the denominator. All right, so the next thing, what else do we need? We have the horizontal asymptote. And here I'm going to do, I put the whole function in here, I just copied it in. The formal definition, this is what we want to see on the test or the quiz. This is what we want to see, even though you could probably tell, look, the degree on the numerator is 2 overall, degree on denominator 2 overall. So this would be the coefficient that would make the horizontal asymptote. You could probably already tell that just from looking at it, but we want the formal definition here, the limit as x approaches infinity. So very large number, infinity plus 3, who cares about the 3? Infinity minus 2, who cares about the minus 2 when you're talking about large numbers? Same here, infinity plus 1, infinity minus 4. So that all reduces to 2 times x, and 5 times x, right? So the x squared is reduced to 1, and there, yes, you are left with 2/5. Okay, so I'm going to put that on my graph again. Just like that. Here's a horizontal asymptote. A horizontal asymptote defines your end behavior. All right, so here's a little bit of a tricky part. It's not that bad, but pay attention here. This is what we're going to need to do. So we're going to do something called an information wave. I know on your notes it has an actual wave, but I prefer that you don't make a wave. All I'm interested is in positive or negative, okay? The wave, I think, is a little bit confusing, so that's what they've been calling it, so I have to use that terminology too. But all I want to know is what my graph is doing in certain sections. So make a number line. All right, the first thing we do is make a number line, and then I'm going to plot my zeros on there. So right here, -3 and 2. So I'm going to put this as a 0 here, -3 and 2 on the number line somewhere. It doesn't have to be perfectly spaced out or whatever, just as long as it's in the correct kind of numerical order. And then the verticals, I'm going to put an X because it's not allowed to be these numbers. So at -1 and at 4. Okay, those are what you're interested in. All right, so right, this is in numerical order, right? -1, -3, -1, 2, 4. So just make sure they're not all jumbled up in there. But it doesn't matter how you space them out as long as they're in kind of order, right? Ascending to descending or descending to ascending, whatever way you want to look at it. Okay. All right, so now what you want to do is tell me what is happening in each and every section of your function. Let me zoom in here a little bit. Okay, in each section. So from here to here, that's one section. From 4 to forever. Between 2 and 4. Between -1 and 2. Between -3 and -1. And between -3 and forever in the negative direction. Okay, so here's a section, here's a section, here's a section, here's a section, here's a section. All right, so what you're going to have to do is take your function, and we always start on this end and move that direction. All right, So we're looking first at this section right here. So pick a number, any number that's in this section. Don't pick the end point, just pick something here like 5 or 6 or 7, but I would pick easy numbers, okay? So let's just pick 5. All right, I'm gonna pick the number 5. I wanna see what is happening to my function overall if I have 5 in here, if I input 5 into X. Now, let me tell you, this is something that students want to do because you're so, like, you want to get the exact answer. You don't need the exact answer. All you need to know is it positive or is it negative? Okay? I don't need to know that f of 5 is equal to, like, whatever, 2,984, whatever it's equal to, okay? I don't know what it is. All I want to know is my function positive or negative in this area? So if I picked a number like positive 5, which is in that section right there, if I put a 5 in everywhere that you have an X, you could say 2 times 8 times 3 divided by 5 times 6 times 1. You could say that and you could get a number, but again, I'm trying to show you a shortcut. All right, this is just a shortcut and it's easier to determine it like this. So you don't have to you waste a lot of time doing that, finding exact numbers. Look, this number right here, 2, that's always going to be positive. Okay. This number right here, if you put in 5 in here, 5 plus 3, that's always going to be positive, right? This number here, 5 minus 2, that's positive, right? 3 is a positive. This number right here, this 5, that's always going to be positive. This, if you put in 5 for X, 5 plus 1, that's positive. 5 plus 4, that's also positive. So a positive times a positive times a positive divided by 3 positives, that whole section there is going to be positive. That's all I care about. Okay? So I'm going to write it down for the next number. Normally, I just use the same thing and I just wipe it out and do it for one. So I'm not copying this function over and over again, but I will in this case. Let's do it one more time and then I'll erase it, I guess. So if you had 2x plus 3, x minus 2 over 5, x plus 1, x minus 4. All right. This 2 is always going to be positive no matter what number you plunk in there for X, okay? Now let's try to pick a number here between 2 and 4. Let's say pick 3, okay? So you could pick 2.5 if you want to. I don't care. You can pick 3.5, 3.4, anything in between here. You're always going to come up with the same answer. Just pick a nice, clean, easy number in between them. 3. Look, so if I use 3, this number always positive. 3 plus 3, that'll be positive, right? 3 minus 2, that will be positive. 3 minus 2 is just positive 1, right? This number always positive. 3 plus 1, that would be positive. 3 minus 4, that would be negative. People, if you have an odd number of negatives, it will be negative. If you have an even number of negatives, it will be positive. Got that? A negative times a negative is positive, right? So you've got one negative, that's an odd number of negatives. This will be negative here. All right, going to do it for the next part here. That's what I mean. I just usually erase it. 2 and the 5 will always be positive numbers, right? You don't see a negative sign in front of them. Let's pick a number now in this section. I don't care what number you choose. It will come up with the same answer. Try it. Try different numbers. I'm going to pick 0. That's a nice, easy number between negative 1 and 2. 0 plus 3, positive. 0 minus 2, negative. 0 plus 1, positive. 0 minus 4, negative. How many negatives do you have overall in this? 1, 2. you have an even number of negatives. 2 negatives become positive, right? If you were multiplying this all out, if you don't believe it, put in the number and check it out. Put in any number in between here and see if you come, right? You can put this function in your calculator if you want to. Put in any number in between, not counting the endpoints, but in between here, and see if you come up with a positive or a negative, if you don't believe me. This should be, I'm hoping this is basic math for you. A positive times a negative divided by a positive, and a negative would come up overall with 2 negatives make a positive number when you multiply them. These are multiplying here, right? They're multiplying in between all of these terms. All right, so next one. I'm going to erase these because these are the only ones that change. These are always positive. Okay, now I'm going to pick a number between -3 and -1 in this section here. Pick -2. All right, -2 plus 3, positive. -2 minus 2, negative. -2 plus 1, negative. -2 minus 4, negative. All right, how many negatives do I have overall? 1, 2, 3. I have an odd number of negatives. If you multiply a negative times a negative times a negative, it will be a negative. Okay. The last section, see what I mean? I just reuse this. Who wants to copy this over 200 times? Nobody. So this is what I usually do. Okay. Pick a number, any number. I don't care. You can use -10. You want to use -10? Use -10. -10 plus 3, negative. -10 minus 2, it's -12, negative. -10 plus 1, negative. -10 minus 4, negative. How many negatives do you have? 1, 2, 3, 4. An even number. Try it. Negative times a negative times a negative times a negative equals a positive. An even number is positive, an odd number would be negative. Okay. All right. So now this is what's key. This is what's key now. We drew all of these earlier. We did the x-intercepts, the horizontal and the verticals, right? First we did the verticals, then the horizontal, using the limit notation. So now we're going to put this all together. I'm going to use your info wave there so you can see it. Let me zoom out a little bit, zoom back so you can see it. Okay, so here you go. We're going to start from this direction. So from everything, from this vertical asymptote to forever. So from here, this vertical asymptote at x equals 4 to forever, it's going to be positive. So look, here we are. That's the section we're talking about here, right here on the graph. We're talking about this part of the information quote wave, all right? So which part of these, this part here, because there's your horizontal, right? The horizontal is going to determine your end behavior. This part or this part, which one is more positive? This section here, okay? So remember, the horizontal determines your end behavior, which means your function is going to be following that. There's the positive. That's more positive than this part down here, right? So I'm doing this section up here now. The horizontal determines your end behavior, and then can you cross? Can you cross a vertical? Never. So what is your function doing? It can't do anything. It goes up like that. All right, positive section, horizontal determines the end behavior, and then it cannot cross that vertical. Okay, next section, from this 0 to this vertical. So now we're talking about here, from here to here on your graph. It is going to be negative. Well, one thing you know, it is crossing the x-axis here. And then which direction is negative, up or down? Down. And then it will never, ever cross that vertical in that direction. Okay? It's at the x-intercept going down because it's negative in this section right here. All right, next. Now we're talking between this vertical asymptote and this x-intercept here. I don't care about the y-axis. We're talking about this to this, okay? It is touching here, and it will never touch that there, and it's positive. So here you are, it's touching at the x-axis, right? It's an x-intercept, and it's going positive in this section from here to here. It's going positive from here to here. So which way is more positive? Up, right? Not down. Up. So it's going to go like this. Can it cross the horizontal in the middle? Yes, it is going positive. You don't want it to just go, right? You're not just going straight up like that. Eventually, it's going towards this direction, towards your vertical there. But it will never cross the vertical. Okay? Now you have the next section here, which is between this 0 and that vertical, so between here and here. It's definitely touching here, it's crossing your x-axis here, and it's going negative. So up or down here. Up or down, negative, you're going down. Okay, last section, between 3 and forever. Remember, when you're talking about end behavior, it's following your horizontal. It's following that, and is it going more up or more down? It's positive here. So you just go in the positive direction and follow that horizontal out. And there you have your first rational function. So again, this is probably the trickiest part. Remember, all you care about is what your graph is doing. Is it positive or negative overall in these sections between your verticals and your zeros? Vertical 0 on this one. So this one's positive. Remember, the ends are determined by the horizontal. So that's how you know that it's starting here. This is the more positive part of this one because of that. It can never cross a vertical. Here, it's going negative. So between these two things, it's going to go down. Between these two things, it's positive. It's going to go up. Between these two things, it's negative. So it's going to touch there, go down. Between these two, it's positive, but it's the end behavior, so it's going to follow the horizontal asymptote. Okay, thank you again. Let's see if I can stop this.